very good morning to all of you. Myself Tina Katpal, lecturer in chemistry from Pandit Jagat Ram Government Polytechnic College, Hoshiarpur. Today the topic of my presentation is chemical equation and its balancing. In this presentation, the topics to be covered are: first, we will have an introduction to the chemical equation. Then we will discuss about the skeleton equation, that what is a skeleton equation. Then third is balanced chemical equation. Next we will discuss the various methods used to balance equations. In this topic, we will study about the methods like hit and trial method, partial equation method, and I will explain these methods by taking examples. In the next topic, we will study about the information given by chemical equation. Next is limitations of the chemical equation, that what are the various limitations of a chemical equation, and in the next topic we will discuss that how can we remove these limitations, and in the last topic there is thermochemical equations. Now let us discuss all these topics one by one. First of all, what is chemical equation? Representation of a chemical change in terms of symbols and formulae of the reactants and products is called chemical equation. That means when a chemical change is represented in terms of their symbols and formulae, that representation is called chemical equation. Means instead of writing the full names of all the elements, we will just write their symbols and formulae. For example, as we know that when sodium and chlorine react with each other, they form sodium chloride. This reaction can be represented in the form of a chemical equation. Here I have written the symbol of sodium, that is Na, and formula of chlorine is Cl2. So these two reactants react together to give sodium chloride, and this arrow represents the direction of formation of the product, means it is pointed from reactants to products. That means instead of writing full name, that is sodium and chlorine and sodium chloride, I have written only sodium symbol, molecular formula of chlorine and formula of sodium chloride. So this is known as a chemical equation. Next, what is a skeleton equation? Another example of chemical equation is when hydrogen and oxygen react to form water. Again, it can be represented in the form of their formulae. Here I have written the formula of hydrogen, that is H2. Similarly, formula of oxygen is O2. They react to form water molecule. Next step is, now we have to count and compare the number of atoms of each element on left hand side and right hand side. Let us compare the number of atoms of each element on both sides of the arrow. If we see towards this side, that is towards the left hand side, there are 2 atoms of hydrogen. Again, this right hand side also contains 2 atoms of hydrogen. But if we compare the number of oxygen atoms, there are 2 oxygen atoms on left hand side, but there is only 1 oxygen atom on the product side. That means their number is not same. Now we have to see that do they match. If they don't, then this is an unbalanced equation. Such an equation is called a skeleton chemical equation. So, skeleton chemical equation is that equation in which the number of atoms of each element are not same on both sides of the arrow. That is why it is also known as unbalanced equation. Next is balanced chemical equation. A chemical equation in which number of atoms of each element are same on reactant and product side is called a balanced chemical equation. So, balanced chemical equation is that chemical equation which contains same number of atoms of each element on both sides of the arrow, that is on the reactant side as well as product side. Means now we have to change an unbalanced or a skeleton chemical equation into the balanced chemical equation. Now I will tell you about the various rules for writing chemical equation. So, during writing a chemical equation, these rules must be followed. First, write the formulae of reactants on left hand side with plus sign between them. So, first of all you have to write the formulae of reactants on left hand side of the arrow by putting plus sign between the various reactants. In the second step, write the formulae of products on right hand side with plus sign between them. In the second step, you have to write the formulae of the various products on right hand side of the arrow, again by placing plus sign between the various products. And finally, in the third step, you have to balance the equation. So, these are the three main rules for writing a chemical equation. In the first step, just write down the formula of reactants on the left hand side of arrow with plus sign. In the second step, write the formula of products on right hand side with plus sign, and in the third step we have to balance that equation. So, these are the various rules used for writing a chemical equation. In the next topic, we are going to discuss about the various methods used to balance the chemical equation. The method used for the balancing of a chemical equation are: first one is hit and trial method, second is partial equation method, third is oxidation and reduction method, and fourth one is ion electron method. So, these are the four methods which can be used to balance a chemical equation. But in this presentation, I will be discussing only first two methods, because only these two methods are there in the syllabus of diploma students, that is hit and trial method and partial equation method. First one is hit and trial method. In hit and trial method, these rules or these steps should be followed. In the first step, the symbols and formulae of the reactant and products are written as a skeletal chemical equation. That means, in the first step, just write down that unbalanced equation which is represented by their symbols and formulae. In the second step, any elementary gas like oxygen, hydrogen, nitrogen, etc. appearing on either side of the skeletal equation is written in atomic state. Means, in the second step, if there is any elementary gas that is to be changed into its atomic state, for example, oxygen O2 has to be changed into atomic form, that is O. Similarly, we will change H2 into H and nitrogen, that is N2 into N. So this is the second step for hit and trial method. In the third step, make the number of atoms equal on both sides without changing formulae of the substances. In the third step, you have to make the number of atoms equal on both sides, that is both sides of the arrow. But keep one thing in mind, that we have not to change the formulae of various chemical substances. So keeping their formulae same, we will balance their number. In the fourth step, atoms of elementary gases are balanced at last. So we will balance the atoms other than that of elementary gases first, and at the last elementary gases are balanced. And in the last step, make the equation molecular. So finally, as we have converted the molecular form into atomic form in the second step, finally make that equation molecular, means convert again atomic oxygen into molecular oxygen, atomic nitrogen into molecular nitrogen, and atomic hydrogen into molecular hydrogen. So these are the various steps which are to be used during hit and trial method. Let us just go through once again. In the first step, you have to write the skeletal equation, then change the elementary gases from their molecular form into their atomic state. In the third step, make the number of atoms equal on both sides without changing formulae. Next step is atoms of elementary gases are balanced at last, and finally make the equation molecular. Now let us balance some equations by hit and trial method using all these rules. First equation is H2S plus SO2 changing into sulfur plus water. This is an unbalanced equation and we have to make it balance by using hit and trial method. In the first step, write down the skeleton equation, means you have to write the equation as it is in the unbalanced form. In the second step, if we count the number of oxygen atoms towards this side, that is on the reactant side there are 2 oxygen atoms, but if we see the product side, it contains only 1 oxygen atom. So to balance the oxygen, in the next step, multiply water by number 2. Now oxygen has become 2, that is the number of atoms are 2 in this step. In the next step, if we compare the number of hydrogen atoms, on the product side, after multiplying water by 2, the hydrogen atoms have become 4, but reactant side contains only 2 hydrogen atoms. So we have to balance hydrogen atoms now. Again multiply this H2S by 2 so as to make the number of hydrogen atoms same on both sides. So after multiplying H2S by 2, number of hydrogen atoms have become 4 on each side. That means now oxygen as well as hydrogen has been balanced. In the next step, we have to balance the remaining element, that is sulfur. If we count the number of sulfur atoms, on reactant side there are 2 plus 1, that is total 3 sulfur atoms are there, but on product side, that is on the right hand side, there is only 1 sulfur. So to balance sulfur, multiply it by 3. So now if we count all these atoms on both sides, they have been balanced. So this equation is called a balanced chemical equation. So we have balanced this equation by using hit and trial method. Next reaction is to be balanced is C3H8 plus O2 changing into CO2 plus H2O. Again, this is an unbalanced equation and we have to balance it by using hit and trial method. In the first step, as we have done earlier, just write down the skeleton equation, that is the unbalanced equation. In the second step, as I have already told you, that change the molecular gases into atomic state. So, we are changing O2 into O. So, the formula becomes, so the equation becomes C3H8 plus O changing into CO2 plus H2O. Now, let us start balancing from carbon. There are 3 carbon atoms on left hand side, but this side contains only 1 carbon atom. So, as to balance the carbon, multiply CO2 by 3 so that the number of carbon atoms become same. In the next step, if we compare the number of hydrogen atoms, the product side contains only 2 hydrogen atoms, but reactant side contains 8 hydrogen atoms. Now, what to do? We will balance the hydrogen in next step. To make H2O 4, we will get 8 hydrogen atoms. 4 is to 2, that means total 8 hydrogen atoms are there on the right hand side, and similarly 8 hydrogen atoms are there on left hand side, means again hydrogen has been balanced. Only one element has left unbalanced. Now, let us balance this element, that is oxygen. This side contains only one oxygen atom, but towards product side there are 3 is to 2, means 6 plus 4, total 10 oxygen atoms are there, 6 in carbon dioxide and 4 in water. 10 oxygen atoms have to be balanced on this side. So, multiply atomic oxygen by 10. Now, in this reaction, oxygen has also been balanced. And in the last step, as we have discussed during writing rules, that change this atomic oxygen into molecular oxygen. So, multiply it by 5O2 so that 10 oxygen atoms are there. That means this equation has now been balanced according to the various rules used in hit and trial method. Next equation which I am going to discuss is iron plus water changing into Fe3O4 plus H2. Again, using same rules, in the first step, write down the skeleton equation, that is an unbalanced equation. Now, what to do in the second step? Yes, as I have already told you that change any elementary gas into its atomic form, that is H2 is changed into hydrogen in the next step. Now, in the third step, count the number of iron towards right hand side. There are 3 iron atoms, but this side contains only 1 iron. So, in the next step, multiply iron by 3 so as to get 3Fe. In the next step, let us compare the number of oxygen atoms. Product side contains 4 oxygen atoms, but this side, that is the right hand side, left hand side contains only 1 oxygen atom. So as to balance this, multiply water by 4. Now, the number of oxygen atoms have become 4 towards reactant side also. That means we have balanced iron as well as oxygen. In the last step, we have to balance the elementary gas, that is hydrogen. If we see this side, that is on the reactant side, there are 8 hydrogen atoms, but product side contains only 1 hydrogen. So, multiply H by 8 so as to balance hydrogen, and finally in the last step we have to convert this atomic gas into its molecular form. 8 hydrogen is changed into 4H2, means again 4 is to 2, that is 8. So, if we see this reaction, 3 iron Fe3 balanced H2 into 4, 8 hydrogen atoms, also there are 8 hydrogen atoms on this side, and if we compare the oxygen atoms, 4, here is also 4 oxygen atoms. So, this is a balanced chemical equation. So, we have balanced these equations by using hit and trial method. Next method which is to be used for balancing a chemical equation is called partial equation method. The rules or the steps followed during this method are: the given chemical equation is split into 2 or more partial equations. This method is used for the complicated reactions. So, first of all, change that complicated equation into 2 or more partial equations. Then, in the second step, each partial equation is separately balanced by hit and trial method, means the partial equations formed in the first step are balanced by using simple method, that is by hit and trial method. In the third step, the balanced partial equations are multiplied with suitable coefficients in order to exactly cancel out those common substances which do not appear in the overall chemical equations. During the formation of partial equations, some intermediates are formed, but at the last we have to cancel those intermediates. So, this point tells us about the cancellation of those intermediates which are formed during the formation of partial equations, means these intermediates should not appear in the overall balanced chemical equation. And in the last step, balanced partial equations so obtained are added to arrive at the balanced chemical equation, means finally we have to change those partial equations which are being balanced into the overall balanced chemical equation. So, these are the 4 steps which are to be followed during partial equation method. Let us recapitulate again. In the first step, change the complicated equation into simple equations called partial equations. In the second step, each partial equation is balanced by hit and trial method, means the simple equations formed are balanced by using the simple hit and trial method. In the next step, intermediate formed are cancelled with each other, and finally various partial equations which are being balanced are added up to get the balanced chemical equation. Let us balance this equation by partial equation method. Equation is NaOH plus Cl2 changing into NaCl plus NaClO3 plus water. This equation is a very complicated equation which can be easily balanced by using partial equation method. First, what will we do? We will change this overall equation into 2 simple equations called partial equations. So, let us split this equation into 2 partial equations. The first partial equation is NaOH plus Cl2 changing into NaCl plus NaClO plus water. That means NaOH combines with chlorine forming NaCl, NaClO and water. Here NaClO is an intermediate which is being formed during first partial equation. In partial equation 2, this intermediate, that is NaOCl, changes into NaCl plus NaClO3. The two partial equations are balanced by hit and trial method. Now let us balance these two partial equations by using the simplest method, that is hit and trial method. In the first step, balanced partial equation can be written as, that is NaOH plus Cl2 changing into NaCl plus NaClO plus water. So let us balance sodium. This side, that is a product side, contains 2 sodium atoms. So multiply reactant side by 2 so as to get 2Na. Similarly, if we see chlorine, here is 1 chlorine plus 1 chlorine. That means 2 chlorine atoms have been balanced. If we see number of hydrogen atoms, there is 2 hydrogen. This side also contains H2, means 2 hydrogen atoms. If we count the number of oxygen atoms, on reactant side there are 2 oxygen. Similarly, on product side 1 plus 1, that is 2 oxygen atoms are again there. That means this partial equation has been balanced. Now let us balance the second partial equation. If we multiply NaOCl by 3, we will get 2 plus 1, that is 3 NaCl plus chlorines are also being balanced, that is 2 chlorine plus 1, total 3 chlorines, oxygen 3. Similarly, here O3, that means oxygen has also been balanced. So this is known as balanced partial equation 2. Now, as I have already told you that this NaClO doesn't appear in the overall reaction, means it acts as an intermediate. So we have to cancel it. If you want to cancel it, here is 3 molecules of NaClO. So multiply this equation by 3 and let us add the two equations mathematically. We will get 3 is to 2 means 6 NaOH, 3 into Cl2, 3 Cl2 plus 3 NaCl plus 2 NaCl means total 5 NaCl. Here 3 NaClO, this side also contains 3 NaClO, means the number of intermediates same. So these will be cancelled, plus NaClO3 which is a product, and finally 3 water molecules. Now this equation has been balanced by using partial equation method. First of all, we change this main equation into two partial equations. As you can see, partial equation 1 and partial equation 2. In the second step, I have balanced these two equations and these are added to get the final chemical equation, which is the balanced one. Now let us balance the second equation, that is O3 plus PbS changing into PbSO4 plus O2 by partial equation method. Again, this equation is to be changed into simple equations which are known as partial equations, as we have already discussed. So the first partial equation is O3 is changing into O2 plus O, and the second partial equation is that this lead sulfide PbS reacts with oxygen that is this nascent oxygen and to form PbSO4 means lead sulfate. Now these two partial